Rồi check lại ha, âm thanh rõ ràng ha. Chúng ta bắt đầu buổi học ha. Okay, so good afternoon everyone. Today we continue to study the course of Physics 1. Okay, this is the second class. So as mentioned before, you should attend my class on site because you have 30 minutes to ask TAs about the content of the lectures, also for how to do homework, how to double check your homework with TA suggestions. Okay, why we need a TA? Because last years we have many students who failed this course because maybe they didn't understand clearly the lectures. Okay, or maybe they didn't do the homework very well. Okay, or some problems about basic knowledge of high school physics and so on. So that is the reasons in these years I request TA to support your study. Okay, at least 25 to 30 minutes per lectures. Okay, so outside of my lectures, you cannot ask TAs, you cannot contact TAs because they are very busy for their project. Okay, so try to utilize the useful times to answer TAs because it's very important to have you fully understand my lectures. Of course, the physics ones is not difficult, but if you would like to get a high score, maybe 1.0 or 1.3 in German score, you need to have the TA support, the TA's helps. Okay, yeah, and so of course we have many on-site class. Okay, I will go to VGU campus and face-to-face teachings. Okay, but now we study online for some first lectures. Okay, so for now I will share my screen to all of you. Okay, of course if you don't understand, you can interrupt me and then I can answer to you. Okay. Okay, so sorry because I have the meeting on Thursday. So this week we move the class from Thursday morning to Tuesday afternoon. Okay, and I hope we will return to the normal schedules next week. Okay, so we review a little bit. Okay, so for review. So last week we discussed about a vector, right? Vectors. So for the vectors, we have a symbol A and we use up arrow, okay? Or sometimes we use a bone face, okay? Yeah, so they are on vectors, okay? So when we mention about vectors, A, we have magnitude A and the phase angle phi A. Okay, so to determine the phi A's, we have two methods, right? So for method one, yeah, we use counterclockwise direction, and you get phi A's is always positive. Method two, we stay here. Of course, we stay as the x-axis. Okay, so now we stay at the x-axis. Okay, you stay here, and then we follow clockwise directions, and phi A must be negative. Okay, yeah. So that is the methods to calculate phi A's. Okay, it depends on you. If you would like to get positive phi A's, we follow counterclockwise direction. If you get a negative phi A, we follow clockwise direction. For example, so here we have for y-axis, we have for x-axis, okay? And then we have for current, the first current, the second current, okay? The third current, and for current, okay? So we have vector A here, okay? Yes. So here you get a phi A is, for example, for 40 degree, okay? Yeah, because we follow counterclockwise direction. Otherwise, you have we follow clockwise direction, okay? So you get a phi A is minus 320 degree, okay? Because we know one circle or one cycle is 360 degrees, okay? So now we can indicate vector A, right? So now vector A is the magnitude of vector A with the phase angle 40 degree, or vector A is magnitude of A with the phase angles minus 320 degree, or we can say we have 40 minus 360, you get minus 320 degree. Okay, yeah. So we finish review. Okay, last week. Now we continue. We come back to the lectures. Okay. Okay, so now we have xy coordinate. Okay, so here is x axis components. Here is y axis component, right? So when we calculate x, okay, so r is the magnitude, right? So x is r times cosine theta, because cosine theta is the theta, okay? Cosine theta is x over r. So that means we get x a r times cosine theta. And similarly, you can get y, okay? So y a r times sine theta. Okay, and then you can get a tan theta. Okay, so tan theta is y over x. And if we would like to get the magnitude r, okay, so magnitude r is the square root of x squared plus y squared. Okay, yeah. Then, yeah, we just review. Okay, so if we have any vector like this, okay, this is vector r, is magnitude of r with the phase angle theta. Yeah. So we can determine y and x. Okay, this one is y and this one is x. Okay, so you can get these formulas as this one. Okay, very easy. Yeah. Okay, so in summary, if we would like to indicate any vectors, you would like to express any vectors, you need to choose xy coordinate, okay, or xyz coordinate. Okay, it depends. It depends on how many components of the vector you need. For example, if we have okay, so if we have yeah, so if we have vector A, right, and we would like to get two components, x and okay, yeah, you would like to get some ax and a. Okay, yeah, you would like to get ax plus ay. Okay, you only need two components. So that means we have xy coordinate. So we would like to indicate a to becomes the summation of ax plus ay plus az. Okay, so that means we need x, y, and z coordinate. Okay, yeah. So if we have two components, we say two dimension, right? Two dimension. Yeah. And if we have three components, we have three dimension. Yeah. So it depends. It depends on the characteristics of physical models. So we have one dimension, two dimensions, or three dimension, and so on. So okay, as many dimensions you want. Okay, so now we go to the 1.3.3. We discuss about basics vectors arithmetic. Okay, so that means we have vector addition, vector subtraction, vector multiplication. Okay, yeah. Yeah. So for, in this slides, we have the information of vector A equal to vector B. Okay, so vector A equal to vector B if, okay, if magnitude of A equal to magnitude of B, and they have the same direction. Okay, A has the same direction with B. Okay, look, A and B both in the same direction. Okay, so we indicate A is a magnitude of A with the phase angle phi A. So B is the magnitude of B with the phase angle phi B. Okay, so A equal to B if magnitude of A equal to magnitude of B and phi A equal to phi B. Okay, here doesn't mean the same magnitude. Here means the same direction or the same phase angle. So we have vector A is equal to vector B. Okay, yes. Okay, now we go to the vector addition. Okay, so we have vector A, uh, yes, plus vector B. Okay, we get vector C. Okay, so here we have vector A, and here we have vector B. Okay, so we can get vector C here. Okay, or vector R. R means resultant vectors. Okay, R means resultant vectors. Similarly, we have vector A plus vector B plus vector C, you get a vector R. Okay, so any vectors, okay, we have this is the tail of the vectors and this is the tip of the vectors. Okay, yeah. So if we have vector A is like this and this is vector B, okay, yeah. So if we have A plus vector B, okay, so we just translate the tail of vector B to come here, right? You get here is vector B, okay, and then you can get vector R uh, here, okay, yeah. So if we have vector A plus vector B plus vector C, so the tails of vector B connect to the tip of vector A, and the tail of vector C connect to the tip of vector B. Okay, yeah, you can get resultant vectors. Okay, yeah, I believe all of you understand because this is for high school physics. Look, the tail of vector A to the tip of vector B. Okay, that is these resultant vectors. Okay, the tail here and the tip here. Okay. Yeah. And remember that any vectors will have tail of the vectors and the tip of the vectors. Okay. Yeah. We have commutative law of addition. That means vector A plus vector B will be equal to vector B plus vector A. And we also have associated law of addition. Okay. A plus B plus C totally is equal to A plus B totally plus C. Okay, yeah. So remember that when we implement the vector addition, okay, you should make sure all vectors have the same unit. Okay, for example, if we have vector A means a voltage vectors V1, V1, and vector B is V2. Okay, V means a voltage, right? So they have the same unit because the unit of V1 is volt and V2 also volt, right? Okay, so they have the same unit. Okay, yeah, they have the same unit, so we can perform vector addition. Okay, so this sentence is very important. Okay, when two or more vectors are added together, they must all have the same unit and they must all be the same type of quantities. Okay, what does this mean, the same type of quantities? So that means we have mechanical energy, mechanical parameters or electrical parameters. So we cannot make additions of one mechanical parameter and one electrical parameter because they have different quantities. Okay, yeah. For example, we have another one. Now we have vector A. We have vector A. That is voltage. Okay, and we have vector B. That's a current. Okay, so we cannot perform A plus B. No, no, we cannot do that. Why? Because the unit of voltage is volt and the unit of current is ampere. They have different units, so we cannot make vector additions. Okay, so this note is very important. Again, if you would like to implement the vector addition, okay, you should remember two things. The first one, they should have the same unit. The second one, they should have the same quantities. Okay, they are mechanical quantities or electrical quantities, thermal energies quantities. Yeah, we have different kinds of quantities. Okay, so you should make sure they must be in the same quantities, the same type of quantities. Okay. Now we move to vector subtraction. Okay, that means we have vector A is minus vector B. So vector A is minus vector B means vector A is plus of minus vector B. Okay, yeah. So if we know minus vector B and we know A, we make this addition, right? We also get vector R. Or we find directly the resulting vectors A minus B. Okay, it's up to you. Okay. So example. Here we have vector A. Here vector A. Okay, so vector A like this, right? And vector B here. Here the vector B. Here's the vector A. Okay, so vector A like this. Sorry, vector B. Sorry. Okay, so vector A here vector A, right? So vector B like this, right? This is vector B. Okay. So we would like to implement A minus B. That means A plus minus B. Okay. So this is B. So this one is minus B. Right? Because minus B is opposite to the direction of vector B. Okay, so here is B, so here is minus B. Okay. So now we have A plus minus B. So I translate minus B to be here. Okay, I can get here. This A minus B. Okay, so now A plus minus B, you can get vector C. So vector C is here. Okay, vector C. So this is vector C. Yeah, this is vector C. And here is vector C, the same. Okay, so this is method one. Okay, so if we use method one, yeah, we need to determine minus vector b. Okay, we need to determine minus vector b, and then we take the additions of vector a and minus vector b. Okay, so sometimes I am lazy. Sometimes I am very lazy, so I don't want to convert vector b to become minus vector b. Okay, I don't want. I would like to calculate directly minus vector a minus vector b directly. Okay, so now we have vector a. Right here, this is vector a. Okay, and this is vector b, right? This is vector b. So this is the tail of vector a. This is the tail of vector b. Okay, so if I connect the tail of a and the tail of b together, okay, so I get here is vector b, right? Vector b. They have the same. They have the same tail, or we say we have common tail, right? Because I connect the tail of vector a and the tail of vector b together. We get the same tail or common tail. Okay, and then we can get vector c. Okay, so remember that. Okay, the vector c, I mean the resulting vector, this is tail and this one is tip. So remember, the tail of vector c should be at the tip of subtrahend vector b. Okay, and now you get this one. Okay, yeah, this is vector c. Remember, the tail of vector c should be connected to the tip of subtrahend vector b. Okay, and the other one here. Okay, so this is two methods. Okay, so it depends on you. Okay, so if you are lazy, you can apply method one, but you should remember the tails of vector c should be add should be added to the tip of subtrahend vector b. Okay, here. Or you get a method one. One more example. Okay, this is for the lectures here, method two means method one, and sorry, yeah, method one, yeah, correct, because this is vector b, so this is minus vector b. Okay, you get vector c. Okay, yeah, this is method one, and this one is method two. This is vector a, this is vector b, so this is vector c. So remember, the tail of vector c resultant vector, okay, must be connected to the tip of subtrahend vector b. Okay, yeah, yeah. Okay, here, look, and yeah, we have some explanation here. Okay, so remember that the tail of the resultant vectors is connected to the tip of the subtrahend. Okay, the subtrahend vectors. Okay, so a minus b, right? So the subtrahend vectors is vector b. Okay, the subtrahend vectors is vector b. So that's the reason a minus b is different b minus a, because we have different subtrahend, right? We have different subtrahend. Yeah. So any questions? Okay, continue. Yeah. So I summarize for you. So maybe we have some example. Okay. So up to now, we have studied vector addition, right? Vector addition and vector subtractions, right? Subtraction. Okay. Yeah. So we make the comparison table. For example, we have vector A, so maybe here is vector A, okay, and this one is vector B, okay, yeah. So if I would like to indicate vector A and vector B into the same coordinate, okay, so this one is Y, this one is X, right? And we have vector A should be here, right? Vector A. Okay, I translate vector A to be here. And vector B should be here. Okay, yes. Yes, so now we have vector A and vector B in the same coordinate. Okay, so so if I would like to calculate vector A plus vector B equal to vector C or vector R. Okay, so I move vector B to be here, right? Or I apply parallel theory. Okay, so we can get vector yeah, we can get a vector R will be here or vector C, right? Yeah, because this is vector B also, right? Right? So vector A, yeah, plus vector B, you get a vector C or vector R. Okay, very easy. So we have conclusion. So vector A belong to the second quadrant. Vector B belong to the first quadrant, right? The first quadrant, the second quadrant. Okay. So when we calculate vector C, so vector C belong to the second quadrant because this is the direction of vector C. Okay. Now, subtraction. We have vector A minus vector B is vector C. Okay. Yeah. So we know this is vector A. Okay. And if we apply method 2, so this is vector A, this is vector B. So we should have the common tail, right? So we here, this is vector B. Okay, so this one is common tail, right? Okay, so and then we can get vector C. Okay, so vector C, so you remember the tail of vector C connect to the tip of vector B. Okay, so you can get here. This is vector C. Okay, this is vector C. This is method 2. Okay, and remember the tail of vector C is connected to the tail of vector B because vector B is a sister hand vector. Okay, so if I apply method 1, okay, so if I apply method 1, I need to analyze a little bit. So vector A minus vector B is vector A plus minus vector B. Okay, so this is vector B, so this one is minus vector B. Okay, so this is vector A, this is vector B, so yeah, we apply parallel theory. Okay, parallel theory. So this is vector C. You know, and they are the same. Okay, this is vector C, this is vector C. Okay, the same. Okay, so anyway, we can apply method 1 or method 2 to determine the vector subtraction. Okay, yeah, so this is example. Okay, yeah, any questions? Okay, I hope you understand fully and you can hear me clearly. Okay, so now continue. Don't worry, I will send the notes to you. Okay, into VGU model. Okay, VGU model here, for example, we have a note, and if you click here, you can see all notes. Okay, will be here. Okay, to have you review the lectures at home. Okay, now we can come back. So now we talk about a multiplication. Okay, so we have vector A, and we would like to apply scalar multiplication. This is scalar multiplication. So that means we have a scalar quantities M times vector H. And this one we say scalar multiplication. Positive. We need to calculate this magnitude. How many? And the phase angle between A and C. So here this is vector A, so it's vector C, so the phase angle here. Okay, how many? Maybe here is delta. How many? Okay. So remember that we have two ways to indicate the vectors. Okay. We use one phase, capital A, or we use A and we use up arrow. Okay, so we have two ways to indicate the vectors. Okay, so now we have coordinate, right? We have x, y coordinate. So this is vector A. Yes, this is vector A. So vector A we have the magnitude is 4, right? And the phase angle is 0, right? 4 and 0. So magnitude B, we have 6. 6. This is vector B. we have 6, and the phase angle how many? 60 degree, right? So here, if we follow, you stay here, and you follow for counterclockwise direction to C vector B. So this one is plus 60. Okay, plus 60. Yeah. And then we know vector C, E, vector A plus vector B, right? Right. Okay. So here is vector B, right? It's vector B. Okay. So vector C should be here. Vector C should be here. This is vector C. Okay. Yeah. So we need to determine the phase angle between C and A, delta, how many? Okay. Yeah. So we have many methods to apply. Okay. We can apply the cosine law, sine law. Okay. Yeah. And many methods. Okay. Triangle for yeah. It's a square triangles. Blah blah blah. Okay. Yeah. So we need to determine the magnitude of vector C. Okay, the magnitude of vector C. So from the first one, we apply cosine law. Okay, yeah, we know what is cosine law, right? Yeah, in the high school. Okay, yeah. So if we apply cosine law, we have c square e a square plus b square. Okay, minus 2ab and the phase angles between A and B. Okay, cosine Riemann. Okay, remember Riemann is the phase angle between A and B. Okay, magnitude, 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 magnitude. Okay, so for magnitude, you should use absolute values. Yes. Okay, do we have the magnitude of vector A? Yes. The magnitude of vector B? Yes. Okay, yes, yes. How about Riemann? How about Riemann? So, look, Riemann. So, we know vector B, right? Vector B how many? 60 degree. Okay. So, from here to here, 180 degree. Okay. So, if we would like to calculate the phase angle between A and B, you get 120 degree because 180 is minus 60. So, you get 120 degree. Okay. So, this is 60. From here to here, 180. So the remainder is 120. Okay, 120. So now we get the answers, right? We have the magnitude of A is 4, so 4 squared, 6 squared minus 2, A is 4, 3 is 6, and remainder is 120 degree. Okay, remainder. Okay, so here you can get 52, right? Minus 48 times cosine of 120 degree. Okay, so you can get a C. Okay, yeah. So please help me. How many C? What is the values of C? Very easy, right? We have 52 minus 48 times cosine 120 degree. Okay, so you get 76. 76. Okay, so you get C squared is 76. So C how many? Yeah, you get 8.72. 72. Okay, so you can get vector C. Vector C. Okay, so square root of 76 means 8.72. Okay, so this is the method one we apply law of cosine. Okay, yeah. Any questions? Maybe I read some message here. Any TA is here? Tông Thanh? Thanh đang màn hình, thấy màn hình không Thanh? Okay, but okay, thank you. So for continue. Now we remember that if mm, okay. So if we have any problems or you don't understand, okay, ask me please. Okay. Now we apply law of size. Okay, just tell me. Okay, because when I use my screens, I cannot see your comment. Okay. Any questions? Okay, good. So now we apply law of size. Okay. So this is the formulas of law of size. Okay. So now we already get Remer. Okay, it's 120 degree. So when we apply law of size, we have psi beta, psi beta. So the opposite to phase angle beta is segment B. So we divide this by B. Okay, is psi Remer. So the opposite of the phase angles are the opposite to the phase angle Remer's AC. So you divide this by C. Okay, so this is the definition of law of cosine. Okay, so do we know vector B? Do we know magnitude of B? Yes, 6. Sine beta, yes, beta how many? Uh, beta how many? We need to determine the beta, right? Because we don't know beta. We don't know we don't know beta. Yeah, we need to determine beta. Beta. Beta is what? Beta is the phase angle between vector C and vector A, right? So C and A. There. Yeah. Okay. So do we know magnitude of C? Yes, we calculate before here. And do we remember? Yes, 120 degree. Okay. So after that, you can guess psi beta E, psi Remer B over C. Okay. So Remer E 120 degree. And magnitude of B, how many? Magnitude of B is 6. And magnitude of C is 8.72. So you can get psi beta. And psi beta is 0.596. Okay. So the double check 100 psi 120 times 6 over 8.72. Yeah, so you get 0.596 and then you can get a beta, right? So beta is psi to the power of minus 1, 0.956. So you can get a beta is 37. Okay, now look, beta is a 37 degree. Now we come back here. We come back here. See, look, this is beta. Beta or delta, you know. Sorry. This is delta or beta, right? Beta. How many? 37. 37.6. Okay. So if we use XY coordinate, you can double check, you know, delta or beta should be than 60 degree because this is the phase angle of vector B. This is the phase angle of vector C and A. Okay, so correct. Okay, yeah, 37.6 less than 60 degree. Okay, yeah, so for our calculation results is correct. Okay, so now we understand how to apply law of cosine and law of size, okay, into the vector operation. Okay, we calculate, sometimes we calculate magnitudes, sometimes we calculate phase angles. Okay, and yeah, it depends on the requirement of the questions. Okay, so and then we have some slides to review law of size, you know, very easy. Okay, I will maybe I skip it or just very briefly present to you. Okay, here we have face angle A, face angle B, face angle C. Okay, so opposites of face A, okay, is a segment A. So we have A divided by side A, okay, equal to B divided by side B, okay, equal to C divided by side C. Okay, yeah, this is law of, or we make inversion. Okay, you can get side A over A equal to side of face B over B and side C over C. Okay, yeah, and then we have yeah, and this demonstration, of course, you know, so I skip it. And we have the law of yeah, the law of cosine. Okay, for example, if I would like to calculate C, okay, so C square E A square plus B square minus 2AB, and the phase angle between A and B is phase C. Okay, phase angle C. So we have cosine C. Because here we have cosine, so this is cosine law. Okay, a cosine rule. Okay, yeah. And similarly, we can get A square. Okay, so A square E B square plus C square minus 2BC and cosine what? Cosine A. Okay, and you know, so on. Okay, yeah, and we have B square E A square plus C square minus 2AC. Okay, cosine B. Okay, yes. Yeah, and this is the demonstrations. Of course, you know, okay, or if you don't understand, okay, just enter TH, they will answer to you. Or I explain here. You know, this is vector A, this is vector, this is C, and this is B. You know, so you get this segment. Okay, so we have the phase angle here. This is phase angle C. Okay, yeah, and this is yeah, A, so we have A times sine C, you can get this segment. Okay, yes. And this is square triangle, right? Right. So if we apply uh, the theorem for right angle triangles, okay, you can guess what? C square E, A sine C square plus this one, you know. This one is, you know, from here to here is B. This is A cosine C. So if we take the B, we take the B minus A cosine C, you can get this segment, right? Okay, so here you get a B minus A cosine C square. Okay, here. And after some modification, you can get this one. Okay, so I demonstrate to you C square E A square, right, plus B square, okay, minus 2AB cosine phi angle C. Okay, yeah, so I already demonstrate to you. We apply law of cosine. We have C square E A square plus B square minus 2AB and cosine C. Okay, yeah. Now yes, we finish the example. Okay, now we talk about a scalar product. The scalar product. Okay, so at the beginning we have a scalar multiplication, right? Multiplication. Now we have scalar product. Okay, scalar products of two vectors. So we have vector A, scalar product, vector B. Sometimes we say scalar product, sometimes we say dot product. Okay, we have the same meaning, a scalar product and dot product. Okay, so the definition yeah, of dot product is magnitude of A, magnitude of B, and cosine phi. What does this mean, phi? So phi is the phase angle between vector A and vector B. Okay, phi, remember, phi is the phase angles between the vector A and vector B. And you should remember we use the smaller angle. We use the smaller angle. What does it mean, the smaller angle? For example, here we have vector A, okay, and here we have vector B, okay. So we have this angle, right? So this angle is E phi 1. Or we have another angle from here to here, phi 2. Okay, so of course we have phi 1 magnitude, okay, absolute value of phi 1 less than phi 2. So we choose phi 1, okay, so here's phi 1. Yeah, remember that. Yeah, so for example, we get example. We would like to determine A dot B, okay, dot product, okay, A dot B. And how many? And we determine B dot A. How many? Okay, and any observation here. Okay, now look, the question gives us, okay, the question gives us magnitude of A. Okay, magnitude of A. So we have A is 6 magnitude. How about phase angle? I don't know. I don't know phi A. We have B, how many? Phi. How about phase angle? Phi B? I don't know. Okay, I don't know phi A. I don't know phi B also. Okay, now I indicate XY coordinate. Okay, so this one is Y, this one is X. Okay, so this vector B here. So this is vector B, right? I translate vector B from here to here, and this is the origin, you know. Okay, the tail of vector B will be at the origins of XY coordinate with vector B, and this is phi B, right? Of course, phi B is positive. I don't know phi B. Okay, how about the A's? Okay, I translate vector A to be here, so you get vector A here. Okay, and this is phi B. This is phi B. Remember that. You stay here. Okay, and then you come to phi B, so phi B is negative. Phi B is negative. Okay, yes. Sorry, phi A. This is phi A. Phi A is negative. Okay, so we know phi A is negative and phi B is positive. Okay, now we don't need to determine phi A. We don't need phi A. We don't need phi B. Because when we calculate A dot B, we only need the magnitude of A, the magnitude of B, and cosine phi. What does this mean, phi? Phi is the phase angle between A and B. Okay, that means phi is here between A and B. Phi. This is phi, right? Right. So how can you get phi? Okay. So phi E, phi A, magnitude of phi A, absolute value of phi A plus absolute value of phi B, right? Because this is negative, this is positive. So if we take the sum, okay, the value is smaller. But when we calculate the difference phase angle between A and B, remember you need to take absolute. Okay, so you get phi A plus phi B. Okay, yeah, sure. How can we determine its angle? Phi. Okay, we apply the formula. So now we get this one, right? So we can get cosine. So you get cosine phi is what? Cosine phi A dot B divided by magnitude of A, magnitude of B. And if we have A dot B, the result is 18. So this one is 18. Okay, and magnitude of A is how many? 6. Magnitude of B how many? 5. Okay, yeah, so you get cosine phi is 0.6. That means phi is 53 degree. Okay, and similarly, if we have A dot B is -21. Okay, Yeah. So we get here is a minus 21 over magnitude of A, magnitude of B. Okay, so you get minus 0.7. Okay, so cosine phi is minus 0.70. That means phi A how many? Okay, how many? 130 degree. Okay, 134 degree. Yes. Okay. So now come back to the question here. So we have A dot B or B dot 8. Okay, we have the same result. We have the same result. Why? Because we just consider the magnitude of A, B dot A. Okay, B dot A. B dot A is magnitude of B. Magnitude of A cosine phi. Phi is the phase angle between A and B and A is the same. So we have the same result. Okay. Yeah. So if we have commutative law, associative law, B dot A is equal to A dot B, and we have the same result. Okay. Yeah. Any questions? So far, any questions?
I have a question, teacher.
Okay. Please ask me, please. So Mr. Tan will make silent, okay, make micro to be silent, and then you can open the micro and ask me, please. Question, please.
I have a question.
Okay.
On that picture, you draw that phi b is bigger than 0, but why phi a you have equal to 0? Why not b?
Where is this? Repeat the question, please.
Um, so on the drawing, you put phi b as larger than 0 and phi a as smaller or equal to 0. May I ask
No,
as to
no, no,
why
no, no. No,
a
this
can
one
be
is
equal to
not.
0 and not?
This one is not equal. I just highlight, underline. Okay. And then what else? Maybe Mr. Tan, keep silent. I mean, keep the micro to be silent, and then you can ask the question again, please. Come on, quickly. We don't have enough time, more times.
So on the drawing, you put phi b as larger than 0 and phi a as smaller or equal to 0. May I
Yes.
ask as to why the equal to 0 for phi a and not phi b?
Yeah, I explained to you. This one is not equal. I just highlight, underline it. Okay, not equal, not equal, please, not equal. Okay, not equal. I just highlight. Okay, underline. And to emphasize, phi b must be positive and phi a must be negative, not equal. Okay, yeah. Is it clear? Is it clear for you? Everything is clear now? Okay, yeah, good. Okay, so for now we come to the vector product. Okay, we come to the vector product. And we have the definition, you know. So we have A cross B. Okay. Because vector product Vietnamese meaning is tích có hướng. Tích có hướng. Okay. So we have vector A cross vector B. Okay. And the absolute or the magnitude of vector A cross vector B. Okay. Here we say cross. Okay. Cross equal to magnitude of A, magnitude of B, and psi phi. Psi phi. Okay, what is phi? So phi is the smaller angle between vector A and vector B. Okay, yeah, just remember the smaller angle I explained to you before, right? Yeah. And the direction of the product A cross B is perpendicular to both A and B. That is perpendicular to the plane or the surface containing A and B. You know, very easy. For example, here we have this is vector A, okay, and this one is vector B, okay. Vector A and vector B are located in the same plane, or in the same surface, okay, in the same surface. And we have A cross B, okay. So A cross B is the vector, you know, is the vectors, okay, will be perpendicular to this surface, okay. And this is the description how to determine the A cross B. Okay, look, the direction of A cross B is further specified by the so-called right hand rule. Okay, this is right hand. Okay, so the four fingers indicate the direction from A to B. Okay, so A cross B. So the four fingers curve from A to B. Okay, so if we have B cross A, so the four fingers will curve from B to A. Okay, remember that. Yes. So here, if we use the the four fingers indicate the direction from A to B, you can get this phi angle, you know. And then the thumb will indicate these vector products A cross B. Okay, yeah. And then if we have B cross A, so you know the four fingers of the right hand will curve from B to A. So we get here is B cross A. Okay, B cross A. Yeah. And then you can get the magnitude of A cross B, E vector A, magnitude of vector A, magnitude of vector B, and then psi phi. Phi is the phase angle between vector A and vector B. So the magnitude of B cross A, okay, the same, you know, the magnitude of B, the magnitude of A, and psi phi. Okay, so phi is also the phase angle between B and A. The same, you know, the magnitude the same, but we have different direction. A cross B going up, okay, upward direction. So B cross A, downward direction. Okay, this one comes from high school physics, just a review. Okay, yeah. So remember that. Remember that. B cross A is a vector. The same magnitude, right? The same magnitude I explained to you before. A is A cross B. So B cross A is the magnitude of B cross A is equal to the magnitude of B plus A. But it is in the opposite direction. Okay, opposite direction. A cross B here and B cross A here. Even though they have the same magnitude but different direction, opposite directions between A cross B and B cross A. Okay, so we conclude that B cross A is minus A cross B. Minus, because if A cross B here, so minus of A cross B, you get a B cross A. Okay, so the vector product is not commutative. Commutative Vietnamese hoán vị. Okay, so we cannot apply the commutative law to vector product. No. Okay, a scalar product, that's okay, but vector product, no. Okay, so now we have conclusion. So we come back to the note here, and we have the comparisons between a scalar product and vector product. Okay, so I mean resulting vectors. So the resulting vectors of scalar products is the constant, okay, or numerical values, and resulting vectors of vector products is a vector. Okay, second one, we calculate A dot B, right, equal to magnitude of A, magnitude of B, and cosine phi, right? And phi is the phase angle between A and B. Okay, so we have A dot B equal to B dot A. Okay, that means you can apply commutative law. Okay, now we have B cross A. Okay, different A cross B. Okay, I mean different direction. Okay, so we have the magnitude of A cross B, okay, equal to the magnitude of A times the magnitude of B times sine theta. And the magnitude and B cross A magnitude, magnitude E, magnitude of A, magnitude of B, and sine phi. Okay, so we have the conclusion: magnitude of A cross B equal to the magnitude of B cross A. Okay, of course, the magnitudes is equal. The magnitudes are equal, but different direction, opposite direction, right? Yeah, opposite direction. Yes, okay. But for here, A dot B equal to B dot A, and then here for scalar product, we don't have direction. That's here I say the resultant vector is constant. That means no direction. Okay, so this is the comparisons between scalar product and vector products. Okay, any question, please? Okay, yeah, sure. If you don't understand, you can type here, okay, or you can ask me immediately. Okay, so now come back. Yeah, and now we have example. Remember that the magnitude of A cross B, the magnitude of A cross B is magnitude of A, magnitude of B, and sine theta. theta is the phase angle between A and B. Okay, so here we have vector A and we have vector B. Okay, so please calculate A cross B for each of the vectors. Okay, so now we calculate magnitude. So magnitude of A cross B, magnitude of A is 3, magnitude of B is 4, and sine theta between A and B is 45. Okay, you get the answers. How many? 3 times 4 times sine 45. Then you can get 8.4. A nearly 8.5. Okay, so we have the surface, and the surface will contain vector A and vector B. Okay, this is this surface. Okay, so we can get the vector C. Vector C is the product is the resultant vectors of A cross B. Okay, vector C. So we apply the right hand rule. Okay, and the four fingers of your right hand will go from vector A to vector B. Vector A to vector B. Okay, we follow the sequence A to B. Okay, A to B. That means the vector C will go out of the surface, will go out of this ring. Okay, here will go out of this page. Okay, of the surface. Okay, because this is surface. The surface contains vector A and vector B, so vector C should be out of the surface. Okay, so here this is A, this is B. Okay, so now we have A cross B. Okay, so we use your right hand, and the four fingers of your right hand will curve from A to B, right? Because we calculate A cross B. So A cross B, okay, A cross B. So if we have the surface, contain A and B, vector A and vector B, so vector C will go into the page. Will go into the page. Go into, this will go out, this will go in. And this is A cross B. A cross B, so go out of the page. Okay, A cross B go in of the page. Okay, A cross B 0 vectors. 0 vector, because for this case A cross B, magnitude of A is 3, is 4. Magnitude of B is 3, magnitude of A is 4, and sine theta is 180 degree. Okay, so sine of 180 is 0, so you can get 0 vector, not 0 constant, 0 vectors. Okay, 0 vectors. Okay, so that's the direction here, 0 vector, and then no direction, because this is 0 vector, no direction. Yeah. Any questions? Very easy, I think, because you already studied at the high school. Okay, so now we have the comparison, right? Comparison table between scalar product and vector product. Okay, so A dot B, magnitude of A, magnitude of B, cosine phi. So you get cosine phi A dot B divided by AB. Okay, this is magnitude of A times magnitude of B. And we have the magnitude of the vector product is magnitude of A times magnitude of B and sine theta. Okay, so this is constant. So the result is the result of scalar products is constant value. Okay, and the result of A cross B is the vector C. A cross B. Okay, so minus vector C is B cross A, right? Yeah. So when we make the reverse sequence, okay, A cross B you get C, so B cross A you get minus C. Okay, you get minus C. So if here we have the surface, okay, the surface. So in this surface, okay, we have vector A here and vector B here, you know, this is the phase angle. Okay, so A cross B, so you get vector C. Okay, so vector C will be upward direction. Okay, A cross B. So B cross A, okay, B cross A, you get here A minus vector C. Okay, so of course the vector C will be perpendicular to this surface, perpendicular to this surface. Okay, yes. Okay, so yeah, I think we should take a break. Should take a break 10 minutes. Okay, so now from 2:30. Okay, so we take a break and we will come back to 40. Okay. Okay, so yeah, come back. Okay, we will continue. Okay. Okay. So for now, we discuss a little bit about components of vectors and what are unit vectors. Okay. So you can see here any vectors with A or vector B, we can analyze the vectors into many components, many vector components. For example, for vector A, you can get vector AX and vector AY, okay, vector BX and vector BY, okay, yes. So for example, here, we have vector A, we analyze vector A becomes vector AX plus vector AY. Okay, here is vector AX, here is vector AY. Or here, this is vector AX, this is vector AY. Okay, because we translate vector AY from here to be here, the same AY. Okay, and for vector AX, we know how to calculate the magnitude of AX, right? And the magnitude of AY. The magnitude of AX is magnitude of A times cosine theta. And the magnitude of AY is the magnitude of A times sine theta. Okay, so if we have vector A, okay, E is vector AX plus vector AY. Okay, so yeah, we know how to calculate the magnitude of AX. So you get AX magnitude plus AY magnitude. This, so we have the problem. Look, this is vectors, this is vectors, this is vector, right? This is vector, right? Vector. But if we say here, this one just magnitude of AX, this one just the magnitude of AY, so we need another vector to indicate here AX and vector AY. So for AX, we use unit vector I overhead and unit vector J overhead. So for x-axis and y-axis, we have unit vector I and J's overhead respectively. This is I overhead, this one is J's overhead. Okay, so I overhead and J's overhead are the unit vectors of x and y axis respectively. Okay, so we have two ways. If you indicate this one, we don't need unit vectors because now it is a vector for itself, because this is up arrow. But now, if you mention the magnitude of Ix and the magnitude of Ay, you should add unit vectors. Okay, you should add unit vectors I overhead and J overhead. So I overhead is the unit vectors of x-axis and J's overhead is the unit vectors of y-axis. Okay, so this is the meaning of unit vector. Okay, yeah. And of course, we know how to calculate magnitude of Ix and magnitude of Ay. Okay, so after that, you also get the magnitude of A, right? The magnitude of vector A is the square root of Ax squared plus Ay squared. Magnitude. Okay, yes. Yeah, we also calculate the phase angle theta. Okay, so now look at this one. We have four quadrants, right? It's the x-axis and y-axis. So we have the first quadrant, the second quadrant, third quadrant, and the fourth quadrant. Okay, so now if we consider the first quadrant, Ax is positive, right? Ax is positive, Ay is positive. If we consider the second column, AX is negative, AY is also positive. Okay, so if we consider the third quadrant, okay, this is vector A, you know, this is AY and this is AX. So AX is negative, AY is also negative. Okay, and similarly, we have the analysis of the vectors in the last quadrant, the fourth quadrant. Okay, so you should remember, so any xy coordinate, this is xy, that means here come from minus infinite to positive infinite. This one is minus infinite to positive infinite. This is 0. Okay, yeah, this is y. Yes. Okay, so now we have the conclusion, right? So if we have, what is it? Oh, this is example. Okay, so if we have the first quadrant, okay, vector A belong to the first quadrant, so AX and AY, magnitude of AX and AY is positive. So if A belong to the second quadrant, AX is negative, AY is positive. So if A belong to the third quadrant, AX and AY negative. So A belong to the fourth quadrant, AX is positive, AY is negative. Okay, yeah. I mean the magnitude, and of course we know vector AE, vector AX plus vector AY are equal to magnitude of AX times I overhead to the unit vector plus AY change overhead. Okay, now example. Look at this one. We would like to calculate the rectangular components for each of vectors shown here. Okay, now this is vector A, this is vector B. This is x-axis, right? Okay, yeah, right. So maybe I copy here. Okay, and then put here. Okay, bus. Yes. Okay. Now look. Okay. Now we consider vector A. Okay, so we have y-axis and we have x-axis, right? So this is vector A. So if I translate vector A to be the origins, okay, so I get the vector A should be here. Do you agree with me? Yes, vector A. So here you can get vector AX, and here we can get vector AY. Okay, so we can conclude that A belong to the second quadrant. So the magnitude of AX is negative and the magnitude of AY is positive. Okay, yeah. So we know vector A. Okay, vector A, E, the magnitude is phi, right? Phi, and the phase angle, Okay, here 70 degree. Okay, so that means the phase angle here 70 degree. Okay, yeah, so we can get phi with the phase angle. To be careful, when we indicate the phase angle here, that means we compare with x-axis. You stay here, okay, and then we follow the counterclockwise direction. Okay, so here you go to the counterclockwise direction, you go to the A, follow with the counterclockwise direction, so you get here. Okay, so you get the phase angle is 110 degrees, right? 110 degree. Okay, so here you get plus 110 degree. Remember that. 10 degree. Okay, because this is 70. So if you stay here, right? You stay here. and we follow counterclockwise, you can get the phase angle here is 110 degree. Okay, 10 degree. Yeah. Okay. So continue. So how can we get Ix? How can we get Ix? Okay. So we have AXE, you know, E magnitude of A times cosine 70 degrees. Okay, the magnitude of A is 5 times cosine 70 degree. How many? Cosine 70 times 5 times cosine 70. You get 1.7. 1.7. And we have magnitude of AY. How many? Magnitude of AY A times sine 70. Okay, you get how many? 5 times sine 70. 5 times sine 70, you get 4.69, so nearly 4.7. Okay, now look, if we follow the condition, you know, AX should be negative. Oh, sorry. Actually, I should ignore this one, right? The magnitude of Ix, okay, is negative. I think that's okay. So now the magnitude of Ix, this is the magnitude absolute, not absolute value, you know, magnitude. Okay, if you make confusion, this is absolute, okay, you are stupid. Okay, so here the magnitude of AX should be negative, but now we calculate, you get 1.7. Okay, so that means AX magnitude should be minus 1.7 because we apply this condition, and AY is positive, so you keep it. Okay, you get 4.7. Okay, so here AY and AX. Okay, AY and AX. Okay, so another method. So if you would like to apply the theory here, you know, so if you stay here and we follow the counterclockwise, you get 110 degree, and the phase angle is 110, and the magnitude of base is 5. Okay, so when we calculate AX, so AX is A times cosine 110. Okay, so you get 5 times cosine 110. You get how many? Please help me to check. 5 times cosine 110, you get minus 1.7. Immediately, we don't need to double check with this one. Okay, and then AY E magnitude of A times sine 110. Okay, you get 5 times sine 110. Okay, you get how many? Okay, you get how many? 5 times sine 110. Okay, you get 4.7. Immediately, you don't need to double check with this condition. Okay, so it's up to you. Okay, so here I say method 1, and here I say method 2. Method 2. Okay, it's up to you. Okay, it's up to you. Let's go on. Method 2. Okay, we have the same result, right? Here. One more example. I have one more example you can understand clearly. I hope. Okay, now look at vector B here. Okay, so now I draw the coordinate. This is y, this is x. Okay, and look, if I translate this vector to be the origins, okay, you get vector B should be here, right? Okay, how many? Magnitude is 6, and the phase angle, how many is 60? So here, this is vector B. Maybe here vector B, and the phase angle here, how many? Look, the phase angle here. 60. Okay, so that mean here is 60 degree. Now we apply method 1 and method 2. Method 2, method 1. Okay, look, for me, I will go with method 1 first. Okay, so now check. This is vector B. This is the first column, the second column, the third column, and the fourth column, right? Okay, so we know vector B belong to the third column. Okay, so that means the magnitude of Bx should be what? This is Bx, right? And this one is By. Okay, should be negative, and By should be negative. This is the constraint. This is the constraint. Okay, so now can we get Bx? Yes. Okay, so the magnitude of Bx is vector B, a magnitude of B times what? This is 60 degree, right? Okay, times cosine, right? Cosine 60. Okay, so B how many? 6 times cosine 60. Cosine 60. You get how many? 6 times cosine 60, you get 3. And we have By. E with the B sine 60, you get 6 times sine 60, and you get how many? You get 5.2. Okay, 5.2. But remember, when we double check with these conditions, double check it. So when double check it, the magnitude of Bx should be negative. Okay, so now we finalize by using these conditions. So you get the Bx should be minus 3, and the By should be minus 5.2. This is the result. Now look. Okay, but sometimes I am lazy, and I don't want to double check whether the vector B is belonging to the first column, the second column, the third column, or I don't know. I don't need. Okay, so now I apply method 2. So when we apply method 2, you should stay here, right? And we follow counterclockwise direction or clockwise direction. It's up to you. But normally we follow counterclockwise direction because the phase angle is positive. If you follow clockwise direction, the phase angle is negative. Okay, you just skip it. You just follow the counterclockwise direction. Okay, you get positive phase angle. Okay, so here if you stay here and then you move to meet vector B. Okay, the phase angle how many? From here to here 180, and you plus 60. So 180 plus 60, you get 240. Okay, so now we have vector BE is 6 with plus 240 degree. Okay, 240 degree. And then you can get Bx. Okay, you can get the Bx. So Bx is the magnitude of B is 6 times cosine 240. Okay, so 6 times cosine 240, you get minus 3. Okay, and then By, magnitude of By is 6 times sine 240, you get how many? 6 times sine 240, you get you get minus 5.2. And then when we compare the results, okay, we have the same. Okay, but for this one, you need to remember you always stay here, always we stay at the x-axis, and then you move to counterclockwise or clockwise. Okay, for example, if if some students, they are very good at study, so they follow counterclockwise. a clockwise direction, that's okay, no problem. So if we follow clockwise direction, you get this phase angle, you know, this is 60, so this is 30, and this is 90, so and you plus you get minus 123. Why you get minus? Because we follow clockwise. Okay, so now we can get vector B. Okay, minus 120. Okay, you get minus 3. Okay, minus 3, minus 3. And then here you have 6 times psi minus 120. Okay, you get minus 5.2. Okay, anyway, we get the same results. Okay, yeah, it's up to you. So, okay, yeah, I believe you have very good, you are very good student. So for any method you can choose. Okay, yeah, I just care about the results. Okay, and you get the correct results or incorrect results. Okay, any question, please? Thanh ơi, bên em nghe rõ không Thanh? Các bạn nghe rõ không? Any questions? Please respond to me. Any questions so far? Okay, maybe I ask someone. Okay, so from Võ Thái Bình, any questions?
No.
So for today, we will check your attendance, okay, and later on, TAs will randomly check your attendance, okay. Just call the 30 or 50 students, okay, to check attendance, okay, yeah. So from yeah, maybe I ask some female students, okay. Are there any female students in my class? No? Oh, Hương Vi, can you hear me? Any questions? Maybe it's secret class. Okay. Okay, so come back. And then here I have some example to apply method 1, okay. But I think yeah, you understand. So I just picked up one example or two examples to explain to you. Okay, so now look, we consider example 1. Okay, so the questions give us the vector A, E, 2 plus 3J's, and they ask us to determine phi A how many. Okay, maybe we have some questions, I hope. Any questions? Okay, no, good. Okay, so phi A. Yeah. So that means if you stay here, okay, and then we follow counterclockwise, okay, you need to determine phi A. You need to determine phi A. Okay, so phi A. Okay, so if you draw these xy coordinate, this one is x, this one is y. So this is 2, 3, so from this is 2, and this one is 3. Okay, so you get this is vector A, right? Vector A. And the question is, what's a phi A? Okay, you stay here, and then you follow the counterclockwise. So which one is phi A? Yeah. Okay. Okay. So first of all, you need to understand vector A belong to the first column. Why? Because AX is positive, AY is positive. Okay. Yeah. Because 2 is positive and 3 is positive. Okay. So we know phi A should be in the range of 0 and 90 degrees. Yeah. 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 Okay. Yes. So how can you calculate phi A? So you have tan phi A E 3 over 2. Yeah. Yeah. Okay, so you can get the phi A E tan the power of -1 3 over 2. Yeah. Yeah. And then you can get 56 by 31. You know, very easy. Very easy. Okay, so the answer is 56 by 31. Okay, now we come to example 2. Example 2. Look, example 2, we have vector A is -2 plus 3 j. And what's a phi A? So if you draw the xy coordinates, okay, so if you draw the xy coordinate, this one is x, this one is y, right? This one is y. Okay, and this is -2, right? This is ax, right? Ax is -2, and ay is 3. So this is -2, and this is 3. 1, 2, 3. Okay, so this one is vector A. Okay, and then if you stay here, right, and you come to the counterclockwise, you come to A with the counterclockwise directions. So you get here. So here is phi A. How many? Here phi A. How many? Okay. Yeah. Remember that you stay at the x-axis, and we come to A. We come to A following the counterclockwise direction. Okay. Of course, we know phi A should be higher than 90 and less than 180 degrees because A belongs to the second quadrant. Okay. Yes. This one is higher. Okay. Yes. How can we know phi A? So first of all, I determine this phi angle. I determine this phi angles, right? This phi angle. This phi angle. This phi angle. Okay. So this phi angle, I say that maybe theta. Okay. So I know tan theta is absolute values of AX over absolute values of AY. Okay, absolute. This is absolute. Remember absolute, not magnitude. Okay, so AX is -2, so we have tan theta is absolute of AX is 2 over 3. Okay. Okay. So you get how many? You get theta theta how many? So for you get theta how many? Theta is tan to the power of minus 1 2 over 3. Okay, so we get how many? Tan to the power of minus 1 2 over 3. Okay, so you get 33.7 degree. Okay, so you get theta here. But actually, we need to calculate phi A, not theta. So phi A is 90 degree, right? This is 90 degree. This is 90 degree. Plus 33.7. Then you get how many? 123.7 degree. Okay, this is phi A. So now you get phi A is 123.7 degree. Okay, inside of these ranges. Okay, inside of this range. Okay, inside of this range, right? Okay, so that's the answer. That is the answer. Or if you don't want to calculate this phase angle theta, no, that's okay. You can calculate phi x here, phi a here, phi here I say phi a and here I say phi. Phi is a phi, you know. So remember, we need to take absolute. Absolute. Okay, so we calculate this one. You know, tan phi a y over ax right here. Ay over Ix and Ay E3, Ax E2, you know, you take the absolute. Remember, this is absolute, not magnitude. Okay, you get 56.31. Okay, so phi here is 180, right? Minus phi A minus 56.31. Okay, so you can also get 123.7 degree. Okay, the same. Okay, yeah. Anyway, yeah, now we have many examples about how to calculate the phase angles of the vectors. Okay, how to calculate the phase angles of the vector. You need to stay here. You need to take the x-axis, and we follow counterclockwise direction or clockwise direction. It's up to you. So, and then you can get the phase angle of the vectors. Okay. Similarly, we have example 3 and example 4. Okay, but for your reference, okay, I will skip it. Okay, and if of course if you don't understand, you can ask the TAs. Okay, they will help you to understand more. Okay, now summary. We also discussed about counterclockwise and clockwise direction, right? So I summary. We have the summary. Okay, so if we have any vector A, okay, we would like to determine the phase angle phi A. How many? Okay, so we know vector AE, vector AX plus vector AY. Okay, or we have magnitude of AX, I overhead plus magnitude of AY, J overhead. So how can we determine phi A? How can we determine phi A? Okay, so we have some steps. Okay, we have some steps. Step one. So for step one, you need to determine vector A belong to what kind of quadrant? Okay, the first quadrant, the second quadrant, the third quadrant, or the fourth quadrant. Okay, step two. Okay, we need to calculate. We need to calculate theta. Okay, for example, here, if here is vector A, okay, yeah, and then you can get here a AX and here a AY, okay, so you need to determine this theta, okay, so we have theta is tan to the power of 1, you know, this is absolute of what? Tan, okay, AY, right, over absolute IX, okay, So I write here, this is, remember, this is absolute value. Okay, absolute value. Yeah, absolute value. Right? Yeah. Right. So, and then step 3, you need to stay at the x-axis, right? You need to stay at the x-axis. And then we follow counterclockwise direction. You can get phi A. Okay, so phi A is theta plus how many? From here to here, 180 degree, okay? Plus 180 degree. Okay, you get the result. So if we know theta, you can get the phi A. Okay, so, and yeah, this is the general procedure how to determine the phase angle for any vector, A. Okay. Yeah. Then, yeah, and now we discuss about unit vectors. Okay, right? Yeah, we already mentioned about the unit vectors. The unit vectors. Yeah. So here do we have the definition, more definitions about the unit vectors. Look. The vector quantities often are expressed in terms of unit vectors. A unit vector is a dimensionless vector. Having a magnitude of exactly 1. You know, a unit vectors are used to specify a given direction and have no other physical significance. For example, here, yeah, I mentioned before, right? If we have this is y and this one is x, okay? So follow x direction, we have I unit vectors, and here you get j unit vector. Remember that the magnitude of I overhead, the magnitude of j overhead. So if we have z-axis, okay, x, y, and z, okay, we have k overhead. So the magnitude of I overhead, j overhead, k overhead is what? Is what? Okay, so yeah, I mentioned before, so AE, AX plus AY. Okay, now I would like to indicate the magnitude of AX plus the magnitude of AY. You need to times, we need to times I overhead and J overhead. Why? Because this is the vector plus vector. So if we don't have I, we don't have J. This is, you know, this is constant. This is constant. So vectors is not constant values. Okay. So you need to add I overhead and J overhead. Okay. So it's up to you. So you can say vector AX plus AY. Okay, vector AX plus vector AY, or magnitude of AX times I overhead plus magnitude of AY times J overhead. Okay. Yeah. This is the meaning of unit vectors. Okay. Yes. Okay. So here we have x-axis. We have I overhead, y-axis J overhead, z-axis K overhead, and we know magnitude of J is equal to magnitude of I equal to, yeah. Okay. Equal to the magnitude of K overhead is what? Is what? Okay. Yeah. So here, you know, this one is vector Ix. Vector Ix is the magnitude of Ix times I overhead. And this A here is the vector Ay is the magnitude of Ay times J overhead. Okay. Then, yeah, we skip this one. We come to here, you know. So if we now we have vector R is vector A plus vector B. So vector A, we get AX I overhead plus AY J overhead. Okay, we analyze this with the A, and this one is with the B. BX I overhead plus BY J overhead. Okay, so here we have I, here we have I. So we have the common variable I overhead. So inside we have AX plus BX. Okay, so we have the common variable of J overhead. So here we have AY plus BY. Okay, so AX plus BX here is RX, here is RY. Okay, yeah, so here. Okay, yeah, so look at this one. We have A, so we have AX, AY, B, we have BX, right? BY. Okay, so we have R is X plus AX plus BX, and AY plus BY. Okay, here is BY. Okay, yeah. Or you can analyze like this. This is B, so this one is BX. This one is BY. Okay, this one is BX. Okay, so AX plus BX, you get RX. AY plus BY, you get RY. Okay, because if here is with the A, so you get this is AX, right? And this one is AY. Yeah, so AX plus BX, you get RX. AY plus BY, you get RY. Okay, just analyze one vector to become so many vector components. Okay, and then you also get tan theta. Okay, yeah, when we know Rx and we know Ry, you can get tan theta. It's easy. Okay, so and now we have three components. Okay, Ax, Ay, Az, Bx, By, Bz. Okay, yeah, so you can get this one is vector Rx, here is vector Ry, and here is vector Iz. Okay, Iz. So you can get the magnitude of vector R is Rx square plus Ry square plus Z square. Okay, and then you can get the phase angle of R with respect to x-axis. The phase angle of R with respect to x-axis, you get theta x, like this, like this, So if we know with the A, okay, so you get here a theta x, okay, here theta x, and here theta x, right, and here a theta y, and here a theta z. Okay, yeah, so we have cosine theta x a, cosine theta x here is ax divided by a, right, here, okay, we don't have absolute values. Then if we have cosine theta y is ay divided by a, okay, this is the magnitude of beta a, magnitude of beta ay, so cosine of theta z is az over a. Okay, like this. Okay, so when we know Rx, we know Ry, we know Iz, so we can calculate cosine theta x is Rx over R, theta y, Ry over R, cosine theta z is Iz over R. Okay, now look here with the A, right? These vectors. So this vector is Ax. This vector is Ay, right? And this vector is Az. Okay, so if we have Ax plus Ay, and then this is Az, right? Az. So you get this vector is vector A. Okay, Yeah, just sum, just a summation of the vectors. Vector A, vector AX plus vector AY plus vector AX. Okay, this is the vector addition, vector summation. Any questions? Okay, continue. So we have examples, but I think we just the big one. Okay, now maybe maybe on. Okay, so now we have questions. We have questions. Okay, now yeah, this is questions. Okay. Yes. Yes. Okay. So we have another example. Another example here. Okay. Okay. Here. I use the unit vectors I overhead and j overhead. So this is actually this one is I overhead. This one is j overhead. To write in rectangular form. Rectangular form that means xy coordinates. Okay, xy form. Each of the vectors shown here. Okay, so here we have two vectors. This is vector A and this is vector B. Okay, so now vector A first. Okay, so this one is y, this one is x. Okay, and we have here is I overhead, here is j overhead. Okay, so we have vector A. If I translate vector A, the tail of vector A to be here. Okay, you can get vector A here. Okay, right? Yeah, so now I stay here. I stay here. And then I follow counterclockwise direction. Okay, from here to here, yes, we get phi A. Phi A. So now we have vector A with phi A. Okay, but the questions give you this phase angle. Okay, that means here 60 degree, right? 60. This is 60. This is 60. So phi A how many? We follow counterclockwise, please. You get 300 degree. Okay, so here is vector A with 300 degree. Okay, and the magnitude is A, so we have A with plus 300 degree. Okay, so if we follow, clockwise direction, right? This A should be what from here to be here, and this A minus, so you get minus 60, or vector A become A with minus 60 degree. It's up to you. Okay, so now we calculate AX. Okay, for example, I do this one, right? So AX is A times cosine of minus 60, and AY is A times sine minus 60. Minus 60. Okay, minus 60. And you get how many, please? We have A times cosine of minus 60, so you get 4. And this one is A times sine minus 60, so you get minus 6.7. Okay, so now you know this is the magnitude. Okay, so now you get vector A is magnitude and 4 I overhead because the x-axis component, okay, minus 6.9 j overhead. So this is the result. Okay, and here you can see the results. Okay, this is the results. Okay, now we have vector B. So vector B, they just give us the magnitude and the phase angle. Okay, but here, how many degree? 128. So vector B should be here. be here, right? And the phase angle how many? 128 degree. Okay, so now we already know vector B is 6 with 128 degree. Okay, so we can calculate Bx and By very quickly, right? Magnitude of Bx and magnitude of By, this is 6 times cosine 128, and here is 6 times sine 128. Okay, you get the results very quickly, right? 6 times cosine 128, you get minus 3.7. And how about sine? Sine, you get 6 times sine 128, you get 4.7. So now we have vector BE, this x, right, minus 3.7 I overhead plus 4.7 J overhead here. Okay, yeah, so this is the answers. This is the answers of vector A and vector B. Okay, now we come back. And similarly, we have with the polar forms, we discuss polar form later. Okay, polar form. Okay, so what is polar form? So any vector A, we can guess AX, I overhead plus AY, J overhead, or you get magnitude of A with the phase angle phi A. So this one is polar form. This one is polar form. This one is XY form or rectangular form. Okay, so now this one is rectangular form. Okay, rectangular form, and this one is polar form. Polar form. Why? Because we have magnitude and we have phase angle. Okay, so this one, this one like the circle. So we have polar form. Okay, otherwise we have XY coordinates. We say rectangular form. Okay, so it depends on the question. So now very easy, you know. I just pick up one, you know, maybe here. We have vector B, right? So vector B, we have minus 1.3, minus 4.8. Okay, so if we indicate vector B into y-axis components, this one is y, this one is x, okay, and vector B should be here. Because Bx is negative, By is negative, so it should be here. And this one how many? And Bx how many? 1.3 minus 1.3 Bx. And By how many? Minus 4.8. So maybe I calculate this phase angle. This phase angle. Because we have vector B is magnitude of B with the phase angle phi B. So phi B, where is phi B? Where is phi B? You stay here, right? And we follow counterclockwise direction. Yeah, here, this one is phi B. Okay, yeah. So if we know this phase angle, for example, here is theta. If we know theta, you plus 180 degrees, you can get phi B, right? So theta is what? So theta, so yeah, theta is tan to the power of what? Absolute value of minus 4.8, so you get 4.8 over absolute of minus 1.3, so you 1.3. Okay, so you get theta how many? Tan to the power of minus 1, 4.8 over 1.3. Okay, then we can get 74.8 or nearly 75 degree. Okay, so here is 75 degree, so you can get phi B, right? Phi B. So now phi B is 180, right? Plus 75 degree. You get how many? You get 254 degree. 254 degree. Okay, yeah, here, you know, nearly the same, you know. Yeah. And how about magnitude of B? So magnitude of B is, so magnitude of B is the square root of bx square plus by square. Okay, so this is 1 minus 3 square plus minus 4 by a square. Okay, so you can get the answers. Okay, the square root of 1.3 square plus 4.8 squares. You get 4.97, nearly 5. Okay, so finally you can get here a 5. Okay, and the phase angle is 554. Okay, so this is the polar form. Okay, from rectangulars. From rectangulars form, now we can get polar forms or vice versa. Okay, so for the final exams, I will ask you to convert between polar form of the vector to becomes from polar form to rectangular form, or vice versa, from rectangular form of vector A to polar form of vector A. Okay, it depends on different kind of questions. Okay, yeah. So, any questions? For any questions so far? So, if no questions, we go to the last session today. Okay, we maybe we don't have enough time, so maybe just 5 minutes left, and then the time for TAs. Okay, so maybe next week we will finish lecture 1 and come to lecture 2. Okay, so now we talk about vector product. Okay, vector product. Maybe it's very quick. I will tell you, and then we can finish lecture 1, I hope. Okay, so now we have scalars product. Okay, or we say dot product. Okay, and we have cross product. Why we know? Because we have dot here, so we say dot product. This is a cross product. Okay, and the next semester, no, maybe next year, so we study DSP. That means digital signal processing. We have another product. We say convolution. Okay, or we have a multi-wise wise multiplication. Okay, yeah, but this one for wise the multiplication or convolution. This, next year's. Okay, you study digital signal processing. Okay, so now we just focus on dot products and the cross product. Here, we have x, y, z. Okay, so for x we have I overheads, y we have j overheads, and k we have z we have k overhead. Okay, yes. So if we have I dot I, you get 1, because A dot B equal to vector A magnitude of I magnitude of B, and then cosine theta. Theta is the phase angle between A and B. Okay, so I dot I, magnitude of I is 1, right? Magnitude of unit vector must be 1. Okay, there, and 1 times 1, how about cosine I and I, so theta is 0. So cosine of 0 is 1. 1 times 1 times 1, you get 1. So I, you get 1. J, you get 1. K dot K, you get 1. Okay, so now if we have I dot J, okay, I dot J is equal to magnitude of I, magnitude is 1, magnitude of J is 1. How about the phase angle? Phase angle between I and J is 90 degrees, so you times cosine 90 degrees. Cosine 90 degrees is 0. 0 times 1 times 1, so you get 0. Okay, yeah, 0. Similarly, this is 0, 0, 0, 0. Okay, so we have the conclusion. So if we have dot product of itself, that means I dot I, you get 1. J dot J, you get 1. K dot K, you get 1. Otherwise, you get 0. Okay, now I summarize for you. Now here, we discuss about we have I overhead, J overhead, K overhead. We would like to calculate A dot B. For example, we have I dot j, I dot k, blah blah blah. Okay, so that means we have 3 rows and 3 columns. Okay, 3 columns. Yes, this one is I j k, I j k. Okay, so now I dot I get 1, j dot j get 1, k dot k get 1. The order is 0 0 0 0 0 0. Okay, so this one is here. Yeah, no, I dot I is 1, I dot j 0, j dot j is 1, blah 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 blah. Okay, so now if we come back to here, so this one does mean this square does mean I dot j, I dot k, j dot j dot j, j dot k, blah 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 blah. Okay, yeah. Now we also have these tables, but now we have A cross B. Okay, now we have cross product. Okay, so if we have cross product, what will we do? Okay, so now we have cross product. Okay, A cross B. Okay, so now we also have this one, right? Yes. Maybe bigger. Here. Of course, we don't have this slide. Okay, so now this is I, J, K, I, J, K. Now we have I cross I cross J, I cross K, J cross I, J cross J, J cross K, K cross I, K cross J, and then K cross K. Okay, here. Yes. Okay, so what's E? I cross I. Okay, so we calculate the magnitude. So I cross I, that means magnitude is 1 times 1 times psi, you know, psi theta is the phase angle between I and I. This is 0, right? So you get this is 0, this one is 0, this one is 0, and then you come back here, you can see this one is 0 0 0. Okay, and then continue. So how about this one, this one, this one, this one, this one, this one? Okay, so we need to follow the sequence. Okay, normally the sequence will be I and then come to J, and J come to K, and K back to I. Okay, you need to follow this sequence. So if I have I cross J, so I can get K because we follow sequence, you know. I cross J, we get K. So similarly, if we have J cross K, you get I. Okay, and then K cross I, you can get J. Okay, so now if we have J cross I, you get a minus K. Yeah, we make the reverse sequence. Okay, so now K cross J, you get minus I. Then if we have I cross K, you get minus J. Okay, so now look, I cross J, you get what? I cross J, you get K. J cross K, you get I. And K cross I, you get J. K cross I is J, so I cross K minus J. Okay, I cross J is K, so J cross K is minus K. And this is J plus K is I, so K plus J is minus I. Okay, So here you can get this one. Okay, here 0k minus j 0 0 of this one just here look 0 j plus I is minus k. Okay, and then k cross I is e k cross I e j blah blah blah. Okay, it's similar, but here they make the columns to the column here mean the row here. Okay, so now we have the comparisons, right, between cross product and dot product. Okay, when we consider unit vectors, right? When we consider the unit vectors, dot product and cross product. Okay, time off. So we will start here. We will start here. And then to remember, we have homework. Even though we cannot finish lecture 1 yet, maybe we need 20 or 30 minutes, but that's okay. You can read at home. Session 1.3.4, you can read at home. Here we have some example. Okay, yeah, and you can understand. Okay, and next week I will explain to you the other slides. Okay, yeah, just some slides. So now you have homework number 1, number 2, number 3, number 4, number 5, 6, 7, 8, 9. Yeah, a lot. Okay, so remember, this is individual homework, not group homework. So that means every student should do the homework for himself or herself. Of course, you can make discussions with your friends, your teammates. Yeah, but when you do the homework, okay, maybe the same ideas, the same thinking, but you need to, you need to calculate for yourself. Okay, write the homework for yourself. Okay, I will not accept any cheating. Okay, that means you copy the answer from one student to the other student. No, okay, we cannot do that. Okay, remember, do the homework for yourself. Okay, so em chủ tâm understands. Yeah, STAs, of course. Okay, so you need to submit your homework on times. Okay, and we have the deadline of homework. We have the deadline of homework lecture 1 should be 21. Okay, November. Okay, 21 November. Yeah. Okay, so we have 3 minutes for questions. Any questions? Any questions? So if you don't have any questions, we stop now. And then this is the time for TAs. Okay, remember that the TA will answer the questions student by student. That means you need to stay at the lecture room. Okay, at the lecture room. And then you raise your hands and you ask TAs. Okay, so TAs answers your questions, and then the other student, they have another question and continue. Okay, answers questions by questions, students by student. Okay, you cannot come to TAs. Many students, okay, come to TAs. Okay, so not good. Okay, so you stay, you keep the position at the lecture room, and then you raise your hand. Okay, after that, ask TAs. TAs will answer to you questions by questions. Is it clear for you? Okay, so finish the lectures. Okay, now for the time for TAs. Okay, goodbye, see you.